Hello, in this video we're going to go over combinations. So when order become immaterial, that means the order of object is not important. We are just interested in selecting maybe our object from n distinct object. So in here we talk of combination and we write it like permutation but with the C and R. That means we select R from n. For each combination, there are r factorial ways of ordering those n chosen objects, and that's why, as you can see here, this is a combination as n gets bigger to 10 and r go all the way to 10, and so the combination value grow up. But for permutation, you see the difference with the same scale, 10 here and 10 here. The permutation is way bigger. The number for permutation is way bigger compared to combination. And let's see why. And so C and R, and that's because C and R times R factorial, that will give us the permutation. So the permutation, when you have, as we've seen in previous example, we have n equal 10 and we try to select 3 out of 10, first, second, third. So the order matter. So what we said for permutation will be n factorial divided by n minus r factorial. Okay? But for combination, the order doesn't matter. So the permutation of 1, 2, 3, for example, the first, second, and third person entering the race, it doesn't matter. We usually say how many groups of 3 can we make out of 10. So once you have one group, it doesn't matter which way this group's gonna sit, that's a permutation. As long as I have one group, that's all what I care about. We count in the groups. We don't count the way or the ordering of these people within the group. So therefore it's a combination. So the number of combinations are a lot smaller because we have to divide by r factorial. So permutation divided by r factorial give us a combination, or I could say this is n factorial divided by r factorial times n minus r factorial. And this is the formula for combination as long as r is between 0 and n. When I divide by r factorial, p divided by r factorial, we get combination. And the same as we've seen in permutations, we have special cases for combination, which is where would be C and O. How many groups of no one you could make out of 10 people? No group, which is one selection, which is 1. So n factorial divided by 0 factorial times n minus 0 factorial. As we've said before, 0 factorial is 1 times n minus 0 is just n factorial. So n factorial divided by n factorial, that will give us 1. Only one way to choose 0 objects from n objects, and which is we choose the empty set, and that's what we have in here. And how many different ways you're going to select groups of one person out of 10? You have 10 different ways. Intuitively, you could answer it. You say, I could choose 10 people, 10 different groups with one person in the group if I have a group of 10 people to choose from. So right here, I would say using the formula n factorial, 1 factorial, and n minus 1 factorial. This is n factorial divided by n minus 1 factorial. And if you remember about factorial, it's 1 times 2 times all the way to n. N minus 1 factorial is 1 times 2 times all the way to n minus 1. So if I simplify this, cancel everything, what I end up with is just n. And that's why, since n ways to choose one object from an object. And the last special case we have is combination when you choose n from n. Well, if I use the formula, as you see, we have n factorial divided by n factorial times n minus n factorial, which is n factorial divided by n factorial and 0 factorial. 0 factorial is 1 and this cancel out, so the answer is just 1. only one way to choose n objects from n object. So let's say you have a group of 10 people, and how many different ways can you make a group with 10 people in it? Only one way, which is the whole group itself. Okay, so only one way. And this is what combination is about, when the order does not matter, and permutation when the order matter. So in the next video we'll see more examples of combinations. I hope this is helpful.